All right. So question number 8 asks you to consider the augmented matrix of a linear system as shown below. The objective is to continue the row operations and describe the solution set of the original system. Basically, what that means is you have your matrix right here. It's 1, -4, 9, and 0. 0, 1, 7, 0. 0, 0, 2, 0. Basically, what an augmented matrix means is there's going to be what's called the equation side and then the solution side. This is the same thing as saying 1x1 minus 4x2 plus 9x3 equals 0, as well as 1x2 plus 7x3 equals 0, and 2x3 equals 0. Notice how I didn't put anything right here because they were all zeros in the original system of linear equations in the matrix. So what it says when it's asking for a solution set, it wants you to find what x1 is equal to, what x2 is equal to, and then what x3 is equal to. So we're going to do that right here. So let's consider back our original matrix. We had 1, -4, 9, 0, 0, 1, 7, 0, 0, 0, 2, and 0. So let's look at the bottom part right here. Notice that this and this are the same thing. You know, one's just without all the variables, one's with the variables. But you can write these as the same thing. And that kind of helps when you're looking at it, trying to find the solution set if you have the variables in front of you. But this right here is the same thing as saying 2x3 equals 0. And so you have to ask yourself right here, 2 times what equals 0? Yep, it would be 0. 2 times 0 equals 0. Therefore, x3 must equal 0. And you have one of your values right there. So now that you have this x3, you can use it in the rest of the problems. Like, this is yours to use, and you're going to want to use it. So looking at your second problem, you see it says x2 plus 7x3 equals 0. Well, we already described that x3 equals 0, so we can substitute that in. So we get x2 plus 7 times 0, because we said before x3 is equal to 0, equals 0, which means we get x2 plus 0 equals 0. So that means x2 must be equal to 0. Right there. Now we have x3 and x2, so we're free to use this in the last row of our matrix. So we have x1 minus 4x2 plus 9x3 equals 0. We said before that x3 is 0 and x2 is 0, so we get x1 minus 4 times 0 plus 9 times 0 equals 0. 4 times 0, 9 times 0 equals 0, so we get x1 minus 0 equals 0, meaning x1 has to be equal to, yep, it is 0. Meaning you have x1, x2, x3 equals 0, 0, 0. And that's the solution to your problem. You can also write this as a vector like this, but I like to write it like this. This you won't get wrong. So that's question 8. Believe you wanted me to do 8, 9, 10, and 14. So let's do 9. I'm going to zoom in a little more so that I have a little more room. Number 9 states the following. Your matrix is going to be a little bit bigger this time. 1, negative 1, 0, 0, negative 4, 0, 1, negative 3, 0, negative 7, 0, 0, 1, negative 3, negative 1, 0, 0, 0, 2, 4. Now remember, this is an augmented matrix, meaning we have our equation side and the solution side. And since this is in the matrix, we can rewrite this as 1x1 minus x2. The same thing as 1x2, but I'm just not going to write the 1 for redundancy's sake, equals negative 4. I didn't write these zeros because, well, they're just zeros. For this next equation, we have x2 minus 3x3 equals negative 7. For this third equation, we have x3 minus 3x4 equals negative 1. In our last equation, we have 2x4 equals 4. So looking at all these equations, we want to ask ourselves what to solve first. Well, what we're going to do is we see 2x4 is equal to 4. And using basic properties of algebra, we can just say divide both sides by 2. And then we end up getting x4 is equal to 2. So that's our first part of the answer. Now that we have x4 equals to 2, we can use this. x3 minus 3 times x4, but we stated above that x4 is 2. So we have 3 times 2 equals negative 1, which gets us x cubed minus 6 equals negative 1. We want to get this x3 by itself, so what are we going to do with this negative 6? Yup. Add it to both sides. So we end up getting x3 equals, what's negative 1 plus 6? 5. So x3 is equal to 5. And now we can use both of these. We have right here x2 minus 3x3 equals negative 7. We have x4, we have x3, we don't have x2, so we're going to want to plug in what we know. x2 minus 3 times 5, because remember we said x3 is equal to 5, equals negative 7. x2 minus 15 equals negative 7. What are we going to do with this 15 to get x2 by itself? Yep. Negative 7 plus 15 is equal to? Equal to 8. So we have that. Now we want to solve one last time. We have x2, x3, and x4, so this one should be the easiest step. x1 minus x2, which we stated before is 8, equals negative 4. So we have to think, what minus 8 equals negative 4? Well, what we can do is we can actually just add this 8 to both sides to get that by itself. So we get x1 equals we're going to get 4. Therefore, our solution set to this problem, x1, x2, x3, x4, is equal to 4, 8, 5, 2, respectively. That's question number 9. The next one up is going to be question number 11. Number 10, actually. All right. Question 10 right here. So we have our matrix right here. 1, -2, 0, 3. And then remember I said that we have our solution side and our answer side. Believe that's what I said above. Our equation and solution. Yeah, my bad. Fuck. Oop, you didn't hear that. We have our equation side and our solution side. Zero, 1, 0, -4, 7. 0, 0, 1, 0, 6. And 0, 0, 0, 1, and -3. So we can rewrite this as x1 minus 2x2 plus 3x4 equals -2. Notice I didn't put any x3 because there's 0 where it should be x3. Our second equation is going to be x2 minus 4x4 is equal to 7. For this third equation, it's going to be x3 is equal to 6. That's actually very, very nice for us to have because that's literally something we can use right off the bat. And then for this last one, we have x4 equals -3. So this is actually a really easy question. We already have two given values, essentially, because when there's only a 1 corresponding to the answer, that just means that x3 is going to equal 6. So now that we have x4 and x3, let's solve this line right here. x2 minus 4x4, we can substitute that in as x2 minus 4 times -3, as x4 is equal to -3, and that is going to equal 7. -4 times -3 is 12, because a negative times a negative is a positive. So we get x2 plus 12 equals 7. We're going to subtract 12 from both sides. And then x2 is going to be equal to -5. We have x2, x3, x4. We just need x1. x1 minus 2 times x2, which we established was -5, plus 3 times x4, which we established is -3, and that all equals -2. So we get x1 plus 10, because -2 times -5 is positive 10, because negative times a negative is a positive, and 3 times -3 means -9 equals -2. So we get x1 plus 10 minus 9 is plus 1 equals -2. We're going to subtract 1 from both sides. x1 is equal to -3. Therefore, our solution set for this problem is going to be equal to -3, -5, -3, 6. I messed this up. Hang on. I made a little bit of an error right there. So what I did is I wrote it in the wrong order. We said x1 is -3. We said x2 is -5. We said x3 is 6. And x4 is -3. So that's going to be your answer. Kind of running out of room here, so let me see if I can zoom in a little more. This is going to be kind of small, I think. Oh well. Nah. I wish I could. So we're going to do question 14. All right, this is where it kind of gets a little harder. This I'll say is one of the more used things in mathematics. I'm a math major. I don't know if Melina told you, but I'm a math major. So I'm actually going to do a new page for this problem because it's big enough to where it warrants a new page. This is going to be one of the most important parts of linear algebra, so I'm going to do my best to kind of teach it well. And I'm going to write down our solution, our system of equations right here. We get x1. I'm going to zoom in a little more. X1 minus 3x2 is equal to 5. We have negative x1 plus x2 plus 5x3 is equal to 2. Then we have x2 plus x3 is equal to 0. So it's important to know how many equations we have and how many unknowns we have. So the way we can tell how many equations we have is how many lines are there. 1, 2, 3. All right, we have 3 equations. How many unknowns is how many columns there are, or the highest number associated with x. So we can tell there are 3 equations with 3 unknowns. What we're going to want to do is we're going to convert this from an equation to a matrix. A matrix isn't that much different from what we're doing right here. It's just we're going to get rid of all the variables. We're going to write that right here. This is going to be the matrix we're going to use. So for the first line, we see we have x1, but that's not really important. What we want to see is the number associated. This isn't as much important as the number associated. So if I had a 2 right here, the 2 would be going into my matrix. As you can see for negative 3x2, the number that would be going into the matrix is negative 3. So we can do that with the equation right here. We see the coefficient attached. That's what's called a coefficient. We have just x1, so that means 1. And then right here we have negative 3x2, so we're going to put a negative 3 in. And then it's important to note the thing I said before with the thing where it's the equation and solution, it's going to be the same here, except what's going on your solution side is on the right hand of the equal sign. So this is going to go into your solution. For this next line, we have negative x1, so that's the same thing as negative 1 times x1, plus x2, it's going to be plus 1x2, and then 5x3. So we're going to put 5 in the matrix. Notice how it's negative 1, 1, 5, 2, and in this we have for our coefficients negative 1, plus 1, 5, 2. For our last line, we're going to have x2, which is 1x2, and x3, which is same thing as 1x3 equals 0. But you may notice, like, this matrix has a lot of blank spots. I mean, what's up with that? Well, you see there's no x3 in the first problem, and there's no x1 in the third line. So what we do whenever that happens is we just put a 0 in. For any place that's not accounted for, we put a 0 in. So now what this is going to do is this puts our set of equations with 3 unknowns into a matrix. This is what you're going to want to do every time. So now that we have this, we need to figure out how are we going to solve this. Well, what we want to do is we want to make sure that the matrix looks like this. Our goal for this matrix is to have zeros right here. And then we can just have numbers right here. This is what you call row echelon form. This is the form that we want to have our matrix end up in. Because when we get to here, we can solve equations like we did before. Right here this is what we call row echelon form. What you'll notice is all these matrices are already in row echelon form because there are zeros on this side. And what this is called is when a point is the first non-zero point in a column, this is called a pivot. We want to make sure that every line has a pivot point. Once every line has a pivot point in this diagonal, we can solve. But only when it's like this. So our goal is going to be to convert this into row echelon form. So we're going to start out by rewriting our matrix. And what we're going to do is these are called elementary row operations. Elementary row operations allow us to convert this to this. So what we can see is we already have a 0 right here. But what we want is we want a 0 that's next to it and a 0 that's above it. So we need to find a way by adding, subtracting, dividing, multiplying rows to get a 0 right here. It's important to note that you want to see the term you have here, and then you want to see what's around your matrix. So we can see we have a -1. We want that -1 to be a 0. So we see, what's around us. We have this 1 right here. We know that -1 plus 1 equals 0. So what we're going to do, but we can't just multiply one term. Multiply, add. We cannot just add one term. What we want to do to one term, we have to do to the rows. So we see we want this to be 0 by adding this 1. We have to add both of the rows. So what we're going to do is we're going to have -1, 1, 5, and 2. And then you want to have 1, -3, 0, and 5. It's important to write down what you're doing. We're taking row 2. We want row 2 to change. So row 2 is going to be equal to row 2 plus row 1. It's important that you write this down because it really helps you keep track of your work. So what we do here is we're going to add these rows. -1 plus 1 is 0. 1 plus -3, well, if that's just 1 minus 3, it's going to be -2. 5 plus 0 is 5. And then 2 plus 5 is 7. We said here that this is row 2 equals row 2 plus row 1. So this is going to be our new row 2. And we can rewrite the entire matrix. Row 1 and row 3 are not going to change, so we're just going to rewrite those rows as we had them before. And then we're going to put in our new row 2. And look at that. We've gotten one step closer to row echelon form because we have 2 zeros in the first column. Now, we just want this to be a 0. If this can be a 0, we are almost done. But you notice here, we have a 1, and we want 1 to be 0. But looking around, we only have a -2 and a -3. So what can we do to make it so that adding something to this will make it 0? Well, sometimes we have to combine row operations. Because if we add -2 plus 1, that only gives us -1. And -1 is not 0, so that would be not what we want to do. But what if we added -2 and 2? That would give us 0. Meaning, we have to find a way to make this 2. And what we can do is we can actually multiply the entire row by 2. We can do R3 times 2. And doing so, we have 1, -3, 0, 5, 0, -2, 5, and 7, 0, 2, 2, 0. Notice it's just because 1 times 2 and 1 times 2 is just 2. Now that we have this 2, we can add this row and this row, and we can get 0 in the pivot column, and we're going to be pretty much home free. So now what we want to do is we want to say row 3 is going to be equal to row 3 plus row 2. And again, the reason we're doing this is because row 3 plus row 2 will get us a 0 in this column. But again, you can't add individual terms. You have to do it to the entire row. So we have row 3, which is 0, 2, 2, 0. We have row 2, which is 0, -2, 5, and 7. We want to add them together. 0 plus 0 is 0. 2 plus -2 is 0. 2 plus 5 is 7. And 0 plus 7 is 7. So this gets us our row 3. And now we can rewrite our matrix. Row 1 and row 2 are not changed, so those are going to be the same. And now that we have pivot form, we have a pivot in each column. The pivots aren't equal to 1, but that's okay for right now. This means we can solve our solution set, and we can find the answer to our problem. This is row echelon form. And this is what you want when you're solving a system with 3 equations with 3 unknowns. So now that we have this, we can rewrite this as we said before. 7x3 is equal to 7. -2x2 plus 5x3 is also equal to 7. And then x1 minus 3x2 is equal to 5. Notice there's nothing here because there's a 0. So we'd just be saying 0x3, which is just 0. So let's look at this first one right here. 7x3 is equal to 7. So 7 times what equals 7? Well, let's divide 7 from both sides. x3 equals 7 divided by 7. So x3 is going to equal 1. We have that, and now we can use it throughout our problem. negative 2x2 plus 5 times x3 is just 5 equals 7. Since we have this negative 2x2, we have this plus 5, we want to get this by itself. Subtract 5 from both sides. Negative 2x2 equals 7 minus 5, which is 2. Now I want this x2 by itself, so we divide both sides by negative 2. x2 equals 2 divided by negative 2. So x2 is going to equal negative 1. Last but not least, we have x2 and we have x3, so we can solve the top equation. x1 minus 3x2 equals 5. We said x2 is negative 1, so we get x1 minus 3 times negative 1 equals 5. Negative 3 times negative 1 is just going to be equal to 3 because a negative times a negative equals a positive. So we get x1 plus 3 equals 5. We want to get x1 by itself, so what are we going to do? Yep. x1 equals 5 minus 3, so x1 equals 2. We have solution for x1, we have a solution for x2, we have a solution for x3. Therefore, our answer, x1, x2, x3, is going to be equal to the set 2, negative 1, 1. That's our answer. Knowing these steps is very important. This is going to be pretty much the fundamentals of linear algebra. So having this down is definitely going to be crucial in your success. If you have any questions, definitely let me know. I'll answer them. And yeah, if you need any help, I'll be here to provide.